In Python, you've added two numbers together using operator plus. You've also used that operator to add two strings together, and two lists. There are other operators that you've used. For example, you can multiply a string by an int. In this video, we're going to show you how you can plug your own new types into this Python syntax. Recall class wordPlayStir from a couple of weeks ago. wordPlayStir is a stir that has one additional method, same start and end. Classes you write can be based on classes that other people have written. It turns out that every class is based on a particular class called Object. Object is a class in module built-ins, and it is the most base type. That means that every other class automatically derives from this class. Class Object contains many of these underscores methods. These methods are often called special methods. Object contains underscores init, underscores eq, underscores stir, and several more. These methods are special because they sort of plug into the Python syntax. Method object.underscoresinit initializes a variable. Recall that underscores init is the method that gets called when you create a new instance of a class. Let's take a look at object.underscorestir. What this notation means is that if I do x.underscorestir, that is the same as calling function stir on x. Let's look at one more, object.underscoreseq. This shows that when we write x == y, that calls method x.underscoreseq with argument y. Most of these special methods are called when a particular syntax is used. Here's our cash register class. We've removed the examples in order to fit more of this on the screen at once. We have our special method underscoresinit. As you know now, this gets called when you create a new cash register object. We also have regular methods getTotal, add, and remove. We're going to add another special method, underscoreseq, that will be called when we compare two cash registers for equality. For this method, we'll consider two cash registers to be equal if they have the same total amount of money. Our method has self as the first parameter, as per usual, and the second variable is the other cash register that we're comparing this cash register to. In our doc test, we'll create one cash register with two loonies, that's $2 total, and we'll create a second cash register with one toonie, also $2. That means that when we compare them, we hope that the result is true. For the type contract, self and other both refer to cash registers, and this method should produce a Boolean. In particular, this method will return true if and only if self and other have the same total amount of money. In order to decide if two cash registers are equal, we've decided to compare the total amount of money. So, self.getTotal should produce the total amount of money in the current cash register, and we want to know if that number is equal to others' total. Let's go modify the main program to try this out. We'll remove the old code, and then create three cash register objects. The first one has two loonies, the second one has one toonie, and the third one has a loonie and a toonie. Let's print what happens when we compare the first one to the second one, and the third one to the second one. When we run this, we see that the first expression produces true, and the second one produces false. Let's step through this in the debugger so we can see exactly what's going on. Now that the debugger is turned on, when we run, we pause right at the very top of the file that we're running. We define our class. Notice now that we've read the entire class definition, including any methods. In the debug control window, we see that we're paused on line 78 of cashregister.py, and that we're about to execute if underscores name equals the string underscores main. Down in the locals section of the debug control window, we see that variable underscores name has as its value the string underscores main, so this condition in the if statement will evaluate to true. Here we confirm that. We're about to create a cache register and assign the memory address of that to variable CR1. We'll create the next two cache register objects as well, assigning them to variables CR2 and CR3. We've been clicking button over, which executes the current statement in its entirety all at once, without showing any intermediate steps. We could instead, if we like, click step, which steps into any methods or functions that get called. We're going to do that here. Now, if you'll recall, we wrote an _eq method in order to hook into the Python syntax for the equals symbol, the comparison for equality. So when I click step, we will actually be taken into that method. Here we go. We're currently on line 27 of cache register.py in method _eq. And we see that also on the call stack that in the main module on line 83, the call to print is what got us inside this eq method. I can click here in order to see the variables and their values in the global scope. And I can click here so that I can examine what's going on inside method eq. What I see in the locals pane of the debug control window is that self has as its value a cache register object. And it's at this funny memory address. As a reminder, that's a hexadecimal number. It uses the digits 0 through 9 plus A through F. So self is the cache register object at this particular memory address that ends in E50. Let's go back up and remember E50 to see which one we are using. That is CR1. So CR1 was sent in as self. Which one is 850? Which one is the other one? That is CR2, hopefully as we expect. If you recall, the total amount of money in the first cache register was $2, and the total amount of money in the second cache register was also $2. So when we execute this return statement here to compare the two total values for self and other, we hope that they compare true. And indeed, when I step here, I see that I'm going to add up the loonies, toonies, 5s, 10s, and 20s for the current cache register, which, as you can see, is the one at memory address E50, that's cache register 1. And when I click step again, it's going to return that value and then call getTotal on the other cache register. Here we go. We're back in getTotal, but this time for the other cache register. Notice the memory address. Clicking once more, we'll go back to the self.getTotal is equal to other.getTotal statement, which should produce true. It will also take us back to the print statement on line 83. Here we go. When I step again, it's going to call the _eqs method for CR3, whose memory address ends in F50. Here we go. Self refers to the same object that CR3 refers to. Other refers to the same object that CR2 refers to. Notice that the object that owns this _eq method is the one that appears on the left-hand side of the comparison. When we step, we're taken into CR3's getTotal method. When we step again, we're taken into CR2's getTotal method. So at this point, we've called self.getTotal, and we're in the midst of executing other.getTotal. When I step again, we're going to exit other.getTotal, we're going to do the comparison, and return to the main program where we started this whole process. Here we go. You'll notice that we don't see anything. That is because the output appears up here in the Python shell where it always has. We're going to do one more thing involving equality. Let's go back up to our eq method and comment it out. We're going to explore now what happens when we compare two variables for which there is no _eq method defined. Here, when we run this, we see that both expressions produce false. That is because Python by default compares the memory addresses of the objects for equality. If there's no underscores EQ method defined in the class, it uses objects EQ method that we've inherited, and that method simply compares memory addresses. Anytime you write your own class, you will need to decide for yourself what it means to compare two instances of your class. Here, we can decide that two cache register objects are equal when their totals are equal. Perhaps we could have been stricter and said two cache register objects are equal when they have the same number of loonies and the same number of toonies, and so on. Or we might decide that two cache register objects are equal only if they are indeed the same exact object at the same memory address.